So my name is Birol. I am the CEO and co-founder of iAlert. We're a SaaS company in Germany. We're doing incident response. And today, we're going to talk about agents, about agentic incident response, and how AI agents are changing incident response. And I'm here to tell you that I think AI agents are going to change incident response in a good way. I mean, not by replacing us, but by empowering us. And I know there is a lot of buzz around AI, and sometimes it's hard to get through to the buzzwords and the marketing speak, right? And I'll try to make this talk as practical as possible. And I'll also give you a hands-on demo. And of course, my goal is also for this talk to be as educational as possible. So yeah, let's get started. Let me start with our vision for the future when it comes to agentic incident response. So we think that we're heading to a future where you no longer will be paged at 3 a.m. in the morning to respond to a routine incident. Instead, your AI teammate will take care of it, and only if the AI teammate is not able to resolve the incident, it will then page you. So after all, if you're into SRE, if you're into DevOps, I mean, you probably weren't hired to do on-call full-time, right? So, and I think that's a good thing. And we'll talk about why. Are we there today? I'd argue no. And that's not what I'm going to show you, or what my overall message is. The reason we're not there, of course, includes the technical limitation and the lack of maturity of large language models. But the other question is, are we as humans ready to hand over such a high-stake task to an AI? So probably not. So there is, I would say, besides lack of technical maturity to do incident response end-to-end for an AI, it's probably also us having issues to hand over such a high-stakes role, right? I mean, it's like you're hiring a junior SRE, and they're probably going to shadow you for quite some time, right? Because doing incident response, the cost of error is really high. Imagine you are on call, and your ability to contain an incident, the company depends essentially on your ability to do that because the company's reputation is on the line. When you're working at a software company, the entire business model is based on that software, right? So it makes a big difference whether it takes you 20 minutes to resolve an incident or an hour, right? So that's quite a stressful situation. And I'd like to start with a question. Who here does on-call as part of their job responsibility, or did on-call in the former job responsibility? Please raise your hand. Yeah, so that's, I always get around about the same ratio, 50%. That's what I would expect from a developer, from an SRE conference. And my next question is, imagine it's 3 a.m. in the morning, you get paged, and there is an incident, right? There isn't, you receive an alert incident. What are the first steps you do? After maybe getting a cup of coffee, what are the first steps you do when you are getting paged about an incident? Check the alert, yeah. For what? Why do you want to look at the alert? What's the goal behind that?
I would get alerted from PagerDuty, so I would check what the service sent that event to PagerDuty.
Yeah, you're checking the alert and to see yeah. So the answer was check the alert and just to see what's the impact, which service is impacted. Anyone else? What else?
To get brief overview of what's happening right now in the system. Maybe something is down, maybe there was something before that. Just brief overview, very, very fast.
Mm-hmm. So the answer is to give a brief overview of what has happened in the last 5 minutes. And how do you do that? How do you create situational awareness just to see what has happened in the last 5 to 10 minutes? Just in really in practical terms, where do you look?
Dashboards usually, and sometimes I have kind of gut feeling that okay, this system maybe there is something there. I should just check. Maybe
Yeah, so two answers, dashboards. And then the second is like human intuition. Like sometimes people have already know, okay, this is probably something I've been dealt in the past, and my intuition tells me I should check that system that's like always maybe flaky. I'm looking for like a few more answers, so please feel free to shout out what's in your head. There are no wrong answers. So we have dashboards, we have like human intuition, like creating situational awareness just to see like which service is affected. Anyone else? Checking log files, yes. Checking log files, right? Find the root cause. Yeah, that's the ultimate goal, right? When you are doing incident response, you're trying to find the root cause. You check the log files, you check the dashboards. Impact, yeah. Yeah, so checking the impact, understanding the blast radius of this incident. Is this like, does it impact a few users or many? These are very critical steps. But I'm looking for another answer is like when you want to find out the root cause. And imagine you're dealing with a service that is where the latency spike, right? And then this service used to work for, I don't know, for the last couple of months, and all of a sudden latency spike. Like, what's the first question you ask yourself? Like, what changed? Exactly. What has changed? Change is the number one reason. These are my boundaries, sorry, because for the camera. Change is the number one reason for incidents to happen, right? People deploy a new patch, a new version of the software. And now picture this. You're getting paged, or an alert is being triggered. And by the time you wake up, an AI has started its investigation. And it essentially does the same steps that you do over and over again, right? It checks the log, it checks the dashboards, it checks what has changed by looking at recent deployments, recent changes in the source code, and then it tries to make sense out of it. And by the time you open up your laptop, instead of seeing this, a raw alert, you see this, a presentation of first key findings, of recommended actions, supported by data that the AI was able to find, supported by maybe metrics, logs. And that's, I would say that's pretty like straightforward for an AI to do. Like when it knows which logs to check, when it knows, okay, I have these list of changes, and maybe I'm connected to Prometheus, and I can like check the metrics, and making like sense of these multiple data sources, that's a pretty straightforward task. So it's not something where I would say I'm not going to trust AI to do this, because I mean, if worst comes to worst, the analysis is just false, and I'll have to do the steps anyway. But like the findings that it presents you are backed by data, and you can clearly see how an agent came to the conclusion it has come to, and we'll see that more in detail. Why is this relevant at all? We are an incident response company. For us, the primary KPI is reducing MTTR, mean time to resolution. And we started affecting that primary KPI by taking the human factor out of it, by looking at MTTA, like making sure that we get immediate human attention to alerts. So when you are sleeping, and we made sure that like, you are waking up and you can start doing your analysis, right? That's how we started. So we basically started by sending SMS, just like PagerDuty, like you said, you were using PagerDuty. We did the same, right? We give you phone calls, we do on-call management, and now we're trying to even make your life easier by taking part of the analysis. And a root cause analysis sometimes can take like 10, 20, 30 minutes. And if an AI does that well, it reduces this to a few minutes. So that's our primary North Star KPI. How can we help you to resolve incidents faster? And this is relevant because like today's systems are super complex, right? You're dealing with microservices, highly distributed, sometimes multi-cloud, and they generate tons of data just by being there, right? And we're trying to take some of the boilerplate tasks from you and help you with an agent that can do these things for you. So AI agents, they essentially serve as teammates. And in case like you don't have a clear picture what an agent is, it's a software assistant powered by these foundational large language models. And in addition, they also take actions like querying your data sources, querying your logging system. Like even if you would like doing some action, right, restarting something, right? And the primary difference between versus like let's say I use just an LLM to generate some text versus an agent is that an agent makes autonomous decisions, right? So if we look at the evolution of LLM apps, we started leveraging AI like 3 years ago, and we started with something we call incident generation. So whenever you are on call and there is something that is has a very like high blast radius and it's impacting a lot of users, maybe you want to like inform those users and update your status page, right? And if it's the same person who is on call and who should fix the issue, we want to make that very easy by making it like typing a few keywords and then you have a beautiful message on your status page that's very accurate and you don't have to deal with like finding the right words. That's how we started. That's a very simple, like from an architectural point of view, it's very simple. You have an LLM, text in, text out. And then we moved over to workflows where you might do like multiple LLM calls and these multiple LLM calls are orchestrated by code. So you have some sort of a script that takes these results of these LLM calls and then produces a final result. In our case, it was post-mortem generation, right? So when we generate a post-mortem, when you're having a major incident and you want to like do a post-mortem meeting, you should have a document that outlines what has happened, what was the impact, like what's the timeline, what actions did we agree on, and then really start the root cause analysis, or not the root cause analysis, but like trying to mitigate this incident like in the future. What actions are we going to make our systems more resilient in the future? And an AI agent like is perfectly capable of like taking all the data from your chat room, from your war room, and then taking the machine-generated data. And we use like multiple LLM calls for different purposes, and then the result was aggregated by code. And now I'm going to talk about agents. And agents are different in that agents have two important design decisions. Like the first is the system prompt, like the instructions you provide to an agent. It's like, what's the identity of that agent? What's the goal of that agent? What are the guardrails of that agent? So it's essentially a prompt that can be like sometimes quite extensive. And the second are tools. Tools are capabilities that you equip with the agent. And this could be, one tool could be, this is my logging system, and you can like query logs by service using any like query language. And this is my like code repository. If you want to check like recent code changes, here are my deployments. Here are my runbooks. And these are tools that you can provide to the agent. And then the agent autonomously decides what it's going to do. So there is no script that tells first do this, first do that. It's provided with an alert. And then based on the alert, it decides its own trajectory until it reaches that goal to find the root cause, right? And under the hood, we're using a standard called Model Context Protocol. Who here has heard of the Model Context Protocol? Please raise your hands. Yeah, so that's pretty much everyone. So it's a standard to do data integration for AI apps. And it was introduced by Anthropic late last year in like December. And I think in March and April, it's also supported by Google and OpenAI. So it's fair to say that it's a de facto standard, and there's like lots of activity around this protocol, and there are many MCP servers already out there, and I'm going to talk about what an MCP server is. So I think it's fair to say that the MCP protocol is probably the future, and we're betting on that. So we're using the MCP protocol under the hood to build the system we're building. And just to illustrate the difference between or the benefits of using MCP server versus building your own custom integration layer. And this is what we started with, right? Today you can like even without the MCP protocol, you could have function calling, you have tools. These are capabilities that existed before MCP. And on the left, let me use this screen. On the left, we see like tool usage without the MCP protocol. And like this custom API integration layer, it's something that we would have to build on our own. So let's say we have these apps running and we want to talk to a calendar, email, or database API, and we would always have to build this custom API integration layer. Whereas with MCP, you have you just rely on the existing MCP servers that are out there, and you can just embed them into your code without having to build the intermediate layer. And your agents gets better over time as the servers gets better over time, or even the underlying model get better over time without us having to do any code changes. So there are two problems that the MCP protocol solves. First is it augments the model with knowledge. So LLMs they have a knowledge cutoff. And the second is it makes integration easier. It standardizes integration. So this is exactly how our AI responder is using the MCP protocol under the hood. So whenever we receive an alert, we initialize the agent, and the agent is capable of doing exactly the things we discussed in the beginning. So it checks your observability tool, it checks like your infrastructure, what's the state of the pods that are affected, and also it checks your code repository. And then it comes up with a root cause analysis consisting of like key findings, recommended actions, and related logs, supporting data. This it's not limited to logs, but could also be like other type of data such as metrics and so on and so forth. Yeah, and the new incident response looks like this, where an SRE agent works hand in hand with an AI agent. And then the SRE, not an SRE agent, an SRE, it works hand in hand with an AI agent. And, and when you are presented with the findings, you're also able to just ask follow-up questions like, what about, I don't know, the database? Are there any new queries that were modified? Can you have a look into that? So just like you would do when you are collaborating for an incident, you can, because the agent is equipped with all these tools, you can do the same. And ultimately, that's the most important thing, and that's ties with whatever I said in the beginning, is the system is architected in a way to be read-only by design, and the human makes the final call, right? So you're presented with data and analysis, and then and recommended actions, but you get to decide whether I want to roll back that deployment, I want to fix that database query, I want to merge that pull request that the AI has suggested, right? So you get to make the final decision. And eventually down the road, as the models, as the capabilities become better, as the reasoning capabilities of these models are more sophisticated, we're probably, and that's closer than most of people probably think, is like an agent will routinely, will handle all these routine incidents for you without you being involved. Okay, let's turn this vision into reality, and let me show you a demo, a live demo. So there is this app I very recently vibe coded, and this app is a to-do list, and it's like hugely popular. But there is this one request I've been getting. So right now, it's capable of like taking to-dos, finish my talk, and drive back to Cologne. But because usually I'm a person who gets things done right away, I never thought about due dates, right? But this is the request I've been getting. Like, can we add due dates? But right now, the to-do list doesn't support due dates. But before this conference, I was able to like finish the PR that supports due dates. And let's commit this due date feature. And let's push this into the master. And if I refresh, boom, we have due dates. And now I can, like for every to-do item, I can just select the due date. But oh, what's this? So I thought it's working because everything was there, but when I tried to set a due date, apparently I introduced some bug. So in the background, I do have, because this app is highly popular, I do have an alert rule that triggers an alert whenever there are too many errors generated by this app. So, and I think we generated quite a few. And if everything works, we should have an alert here. And if I open this alert is triggered by Grafana. And you can see that the AI has already started its investigation. So by the time, like, if this was a real incident and if this happened out of like, working hours, like by the time I open my laptop, probably the investigation is finished. And in fact, it's already finished, right? So you can see here the key findings that the AI came up with. Here is just for the sake of transparency, that you can see like what the responder AI did. It retrieved deployment events. It analyzed logs from Loki. It just used these two data sources, although it was equipped with more. But apparently, like these two data sources, they were enough just to draw the conclusion, okay, I know clearly what the root cause of this failure is. So let's have a look at the key findings. Application errors occurred due to no such column, due that. So apparently there's a typo when updating to-do due dates, causing failures in the to-do update feature. The root cause is a typo in the SQL update statement. And a deployment was made just before the alert. So that's the deployment we just saw that I made while I was doing the talk. And here are the actions. You can see there are two AI-generated recommended actions. And the first is, let's update our status page. So because, again, huge blast radius, super popular app, and that's why I would like to inform my, my users. So I'm going to update my status page. So let's do that. It generates also an incident for me because it knows exactly what happened. And I'm like, it selected the service, it generates the message. I'm trusting that, it works well. Let's not notify the people because we think we'll fix it immediately. Hopefully no one will notice, right? And then fix the typo. Maybe we quickly have a look at the status page. Yes, so it's updated. There is an incident published on our status page. And I actually don't know how to fix it. Let me ask AI what the actual fix is. So now it's thinking. The fix to correct the typo in the SQL update statement in the source code. Specifically, you need to change the due dat to due date in the SQL statement found in database.ts. So let's do that. Let me open VS Code. And let's fix that. So let's go back. Check this. Due dates are there. And oh, I forgot to save. Let me save. I'm an IntelliJ user, so in IntelliJ we never save. But with VS Code, I make these mistakes over and over again. Yeah, so we fixed the issue. That's good. Now let's, because this app is widely popular, I've already deployed it on our cluster, on our Kubernetes cluster, which is here. And I would like to simulate a second incident. So this, the first demo was on my local machine. This is now live on the internet. And we're now simulating in a memory leak, right? So this is a Node.js server that's when there are too many requests, memory usage increases. And I have the running Kubernetes cluster here. So right now the memory limit is like 128 megabytes. And let's trigger this memory, this out of memory error by like doing a few refreshes. I think now it's hitting the memory leak. So you can see the page is not loading anymore. And I'm about to get another alert. So I muted my notification so I'm not disturbed during the conference. But usually I would get an alert using phone, using push notification. But you can see here that the part where this app is deployed was killed. And again, let's have a look at the key findings of the investigator. The application experienced a memory leak as indicated by repeated log entries, total leak memory, 50 megabyte, so on and so forth. And this led to the process being killed with zig kill, likely due to out-of-memory conditions. The deployment occurred just before the alert, involving a commit that's probably not related, including a new logic for overdue and due soon task. So sometimes it tells you this is not related. In this case, it just mentions it without like judging it. And what are the recommended actions? Review and fix the memory leak in the application. Let's try to fix the memory leak just by increasing the memory limit in the cluster itself. So there is a Kubernetes agent running, and where the AI responder is also has access. And let's just try to fix the memory leak just by talking to the AI, right? Let me increase the size, and I'm going to ask how do the memory usage look in. So just ask him to check Prometheus for whether there was an increase in memory usage. I mean, obviously there was. And sometimes, like here, we're dependent also on the response times of course, the AI providers were calling. Sometimes it's really quick. Sometimes it takes a few seconds. In the meantime, let me. Can you increase the memory limit to 500? So let's refresh and see whether it's doing something. So it's in the background. It's like now doing queries, and it decides completely on its own, like which metrics to look at. And usually, it knows that okay, I'm going to look at the metrics specific for this application, and I'm going to look at memory consumption metrics. Let's try to overwhelm the agent. So let's maybe ask another question and see if it's able to do multitasking. Oh yeah. So apparently, in the background, it's still analyzing Prometheus, and now it's patching the Kubernetes pod limits. Let's see if it has applied. Memory limit request snappy to do have been increased to 500. Let's validate this on the cluster. Yeah, you can see here that the memory limit is now changed, and let's see if the fix is working. Oh yeah, perfect. I can do as many refreshes as I want. So. That's a short-term fix, of course. We need to make sure that the memory leak is fixed, but we now fixed it just by increasing the memory limit and, so reducing the impact. And that's usually what you would probably do when you are like in the middle of incident response, just fixing the impact, and then maybe you take care of fixing the actual bug. Okay, we are now moving on to questions. I would like to just wrap up maybe for 30 seconds. I think the overall message of this presentation is embrace AI agents, and think of them as like teammates, letting you do more strategic work, letting you focus on the things that matter, like architecting resilient systems, and like letting AI take care of like boilerplate tasks, and then it's all about reducing toil, right? And that's perfectly in line with the SRE ethos, automate everything that can be automated. And if a root cause analysis can be automated, like why wouldn't I do it? And I just also showed you, like, if you were to build this, I mean, that's, I don't want to say it's like super easy, but definitely something like you can achieve, right? By, like, for example, adopting the model context protocol, by like plugging in, implementing a middleware where you have alerts and then you start the investigation. So yeah, the future isn't human or machines, it's human and machines. So now we have a few minutes for questions. Thank you. Thank you.
Possible. I'm trying to understand. So, in real world, we typically have metrics and logs from thousands of systems, and as a RIF who making this investigation, need to have some prior knowledge how to make the pieces. And AI, even if it has all intelligence, without additional training, won't be able to. How do you train AI to be able to do it?
Yeah. So the question is. When you want to look at metrics, the amount of data is huge, right? There are thousands of metrics. And how does the AI know to which metrics to look at, right? That's the question. And how can you train or teach your intuition to an AI? Because intuitively, when you see an application, you know what to do. You know which metric to look at. Maybe let me quickly check whether, because we still have that Prometheus query running, right? So let me see if it's. If it has completed, and then I'm going to answer your question. Oh, yeah, it did. So the Prometheus data for the pod snappy to-do sketch shows a steady increase in memory usage over the observed time window. So here it was able to find the right metrics. And of course, this is not magic. So it needs to have some sort of indication what to look at. And in our case, when we have an alert, the alert includes on which pod this service is running, what's the name of the application, and then if you're looking for memory metrics, then it's able to understand, okay, I'm going to maybe check memory usage over time. So yeah, the answer is it needs to be somewhere. If it's not, if the alert doesn't include any information at all about the service, then it's going to have a hard time. And that's what, in our experiment, and this is, by the way, brand new. This is something that is not available to all customers yet. And that's one of the questions we need to make sure it's working properly. And that's one of the challenges. But yeah, that's it's working. But if there is some indication what to do, right? If it's included in the alert. Next question, please. Mm-hmm. So the question is, in order for the AI to do its job, it needs a lot of credentials. It needs the same access as you have, right? And I think that the question is what are the best practices to audit this? Is that right? Yeah. So first of all, it's going to have it will use the same way. It uses the same methods to access the system as you do. It goes through the API, so you provide it with API credentials, with API keys. And what we recommend is of course, just as you would do with maybe someone who just recently joined your company, give them read-only access first. So make sure that they cannot do any damage. And of course, and then there's not only one agent. Every team can have their own agent, right? And that's the way we think the system should be designed. You don't have this one God agent that has access to everything for the entire company, but only is limited to your team's permission scope, right? And our recommendation is to start with read-only KPIs, and as your confidence grows, then maybe elevate the permissions. And the question of auditing is right now the level of transparency we're showing you is limited. It's just telling you, okay, what step it's performing. But we do have all the data, so we need to find a good way, in terms of UX, to clearly show you when an AI is doing an agent. Of course, you have the audit capabilities of your source systems, but you want to centralize this, right? But that's something that we clearly need to solve. Thank you for the questions. Unfortunately, we're out of time. I will be around, and I also brought my co-founder here as well, who is also like a DevOps engineer who built some of that stuff. So if you're interested in more technical questions, a deep dive, feel free to approach us. We'll stick around for a few hours, but then we need to head to Germany because we have a 10 hours drive in front of us. Thank you, guys.